Well, let's wrap up this series on demystifying IPv4 subnetting by just quickly talking about a Class A example. And boy, do corporations have it made. They'll typically use the 10.x address space inside the walls of their corporation because, of course, this is going to give them such incredible flexibility with all the bits they can use for subnetting and the bits that they can have left over for host addressing. Sure, what an organization will often do is say, all right, we're going to use all 8 bits in that second octet, and so we'll have a 10.x address with a 255.255 mask. That's, of course, a 10.0.0.0/16 in prefix notation. And then what they can do is they can further subnet where they need to. And I'll give you an example of that here in a moment. But yeah, notice this scheme gives us plenty of networks and is leaving plenty of host bits. In fact, so many that we can further subnet those. So here's a look, of course, at 10.0.0.0 under this scheme. The first usable would be 10.0.0.1, and then we'd have 10.0.255.254. We could then pick up with the 10.1 network. Yeah, first usable 10.1.0.1, and then last usable 10.1.255.254. As I said, what organizations will frequently do is they'll have this large /16 network, this large /16 network, then they'll go ahead and take the 10.2 network and further subnet it, maybe using a 24-bit mask, and the 10.3 network further subnetted to /28. So variable length subnet masking is wonderful for organizations to be able to go and carve out just those size networks that they need. And you will see this all over the place in common networking today. For example, one of the things that's so popular is cloud. And in cloud technology, you will create your own private network. Here in AWS, this is called a VPC, or virtual private network. I'll just create a sample VPC for us here, and notice what's going to happen when it comes to addressing. Yeah, we are going to give a classless inter-domain routing block size, and notice it needs to be between /16 and 28. They give an example for us of 10.0.0.0/24, but I can go in and say, hey, I want to start with the /16 block size. So this is the overall address space that this VPC will utilize. I now create the VPC, and I go and create my subnets inside it. And notice I'm going to select our sample VPC right there, and I'm going to create my first subnet, and sure enough, notice what it does. It has our IPv4 VPC CIDR block that we selected, and then it gives us a little subnet calculator down here to create the addressing for this CIDR block. So I might say, all right, it's 10.0.1.0/24 that I want to use out of that space. Notice it gives us the number of IP addresses. You got to love it. And if I increase the mask size or decrease the mask size, it's going to adjust the number of IPs that we can accommodate appropriately. But yeah, you see how you can do it. You can go in and build your addressing scheme with great flexibility, thanks to starting with that Class A private address space, as we saw in this video. Well, thank you so much for joining me in this series where we took a look at subnetting in great detail.